Hello everyone, welcome back to the Technology Innovation Hub. It's going to be a session from DevOps portal. This time it's going to be a session for senior level, mid-senior level, which is going to be a session from CP10 onwards, competency level 10 onwards. Right, so let me share my screen. I think now most of you are aware the order that this channel is presenting videos, the hierarchy, right? Okay, if you take a look at our playlist and you can see the DevOps portal, right? The DevOps portal, I think the videos has been there from CP1, and after the industry overview, this is for very first beginners building a basic CI/CD pipeline. And after that, also we have published the introduction to Docker node, then you have Minikube introduction, and likewise CP3. Still, everything was under CP10, which is at the beginners level. So while continuing this series, now what is going to happen? We are going to start mid-senior level series, which is starting from CP10. That is what's going to start now, right? All right. So as the first session in that, so what we are trying to do here is to create a Kubernetes cluster manually. That is what we are going to do, right? Kubernetes cluster creation, but manually, right? I think most of you are aware of Kubernetes cluster by now, since you will have done the practicals with Minikube cluster, single node cluster, right? So in the industry, what you get is not Minikube. What you get is multi-node production level Kubernetes cluster, right? So I mean, minimum the cluster might have single control plane and 2 worker nodes, but that's also not suitable for production, right? A real high production workload should be deployed in a Kubernetes cluster where you have multi-master. I mean, even the control plane, what is known as a master node, also should be ready to be high available, right? Sharing between the API interfaces, right? API servers should happen, right? So that means in a real production workload should be deployed in a Kubernetes cluster, which we have multi-master nodes plus at least 5 to 10 worker nodes, right? So that is what, right? And worker nodes can go up to, I mean, maybe 100 plus, right? So like this. So now what you're trying to do here, without right away starting to understand the Kubernetes cluster by using a managed cluster, right? You know, a lot of cloud providers, they provide managed clusters, like AWS, they have EKS, right? The EKS cluster, right? And Google, I mean, Google, they have GKS, Azure, they have AKS, Oracle, they have OKE. So likewise, they have managed clusters, right? Managed means the master node or the control plane is not given for end user. They are telling they are managing that, and only the worker nodes part is visible to us, right? And we have to deploy our workloads right there, right? So containers will appear to us, but still the master node part is totally managed by the cloud provider. But those clusters we can, I mean, start maybe within 5 minutes, right? 5 minutes, 10 minutes time. For example, if you want to run a AWS managed cluster, I think EKS control will allow you to do that. And even in the graphical interface, you can do it, right? Using the click wizard, you can do it, right? And as you are also same, right? AKS cluster, even in the command line within one shot, even you can, for learning purpose, within 5 minutes, you'll be able to run the AZ command and run the AKS cluster creation command, and right away it will be starting, right? Very simple. But that those are going to be managed clusters, right? But see, if you want to learn how Kubernetes is really working, right? I mean, what is the cluster architecture, right? And what are the internal components, how the workloads are deployed, what are ports and the port network, right? What is CIDR, right? And likewise, so there are a lot of things to learn, right? And container runtime and all. So then we need to start a cluster not as a managed cluster. We need to do it manual cluster creation, right? But then again, on the other hand, creating a cluster manually is not a basic task. It's not a basic task, right? Because we need to have a little bit of technical understanding on what are the requirements made. You need to know the Docker, right? The Docker and Docker runtime, because most of the cases, our resources in the industry for container runtime, what is being used is Docker, right? Because in cluster there is some component called container runtime. So what that is, most of the cases, most popular one is Docker runtime. We have CRI and all, but so that's why we need Docker knowledge. And not only that, we need some but Linux knowledge, right? Okay. So not only that, Kubernetes basics also required. So likewise, and a clustering knowledge, basic knowledge, right? So likewise, there is a whole lot of prior knowledge required to understand how this manual creation is done. So that's why you don't see that much of I mean, practical scenarios even in the YouTube, right, to do it manually, right? But anyway, if you want to get ready for the even the Kubernetes administration exam, right, it is a must for you to get familiar with manual cluster creation and architecture as well, right? So what I'm trying to do here initially, let's create a cluster manual. I will walk through all the steps plus all the practical demonstrations. And thereafter, I'm going to continue this series into the Kubernetes architecture as well, right? Because we need to understand Kubernetes architecture deep dive, right? And I will walk you through all of those steps little by little. All right. So, okay, now explanation is enough. Let's get back to work, right? So let's start. So here are the requirements. So this cluster creation is done on AWS. AWS spinning up AWS EC2 instances, right? Because that will be easy, but the only requirement is we won't be able to create the cluster under pre-tier, right? Because pre-tier micro instances will not be sufficient to occupy the workloads that is this cluster is going to run. So therefore, we need to get a step one, just a one step ahead. We not to have a massive server here, right? Just a one step ahead. So we need to have T2 medium servers. That will be enough for us, right? Because here we are trying to build up a learning environment. Like we are trying to learn here how the cluster can be created manually, right? This is not suitable for production. So we will create a production suitable cluster after this one, right? We will go to the COPS cluster creation later using the COPS tool. That is step 2 for us. So we need T2 medium, 2 CPUs and 4 GB RAM. That is the hardware requirement, right? So we will use Ubuntu servers, no problem. LTS, I think in the AWS, the latest is 20.04, so that is fine. I think the Pocal release, right? So that's okay. So and SSD volume, that's fine. A system user with sudo access, that's okay. That's we have Ubuntu user is there, right? And we can switch to root. Yeah, this is the Kubernetes cluster communication default port. So we will stick that port by default. So the master server need to have this port open, right? So I mean, open the below port on each instance. So it is not a must to open in each instance, even though I have mentioned, but no harm, right? So you can just open it only on master node, because the worker nodes need to connect to the master node. So once it connecting, the default TCP communication will take place over 64434 port. So that's why we need this, right? You can test it without opening this port. What will happen? The worker nodes, I mean, it will get hang. It won't be able to join the cluster. It won't be able to do the handshaking with the master node, right? So that's the first thing, right? Then perform the below steps in all node, right? So let me, while explaining, let me do the practical as well. So the very first thing, so we need to spin up a EC2 instance with T3 medium and Ubuntu. So let's do it, right? And let me go to the, all right. So I have logged into my EC2 account, so AWS account, right? So let me launch the instance. And don't try to launch these all 3 instances at once, right? Because again, we need to be cost optimized now, because it's time consuming. So just make sure the first instance, I mean, there are common tasks to be done, right? So for example, kubelet and Docker runtime. So these things are common for all the nodes, no, all the cluster nodes. But what I'm telling is, when you launch in the instance, do one instance at a time, complete one instance, and go to the second instance. Likewise, we are going to have 3 nodes, right? So complete the configurations on the master node. Make sure everything is okay in the master node. Then start your worker node 1 and worker node 2 in sequence. Don't do it parallelly, because if something goes wrong in the master node configurations, since we have started other 2 nodes, it is just costing for you, right? Because pay as you go model, uptime will cost you. So we know that basics on EC2, right? Okay, so therefore I'm going to initiate only the first instance for the master node, right? So as I mentioned, I'm going to use this type of instance, Ubuntu 20.4 and SSD volume AMI. So I am using not ARN, I am using 66 x86 64-bit, right? So selecting that. Okay, so as I mentioned, we can't go ahead with nano or micro instances because CPUs and the memory is not enough for our cluster. So we need to go at least T2 medium. So that's why I mentioned it just one level, one jump we are doing, right? We have no need to go for this T3, T4, no nothing, right? So only T2 medium. So there won't be big cost for you here, right? And T2 medium, so that is what we are taking, T2 medium. And okay, let's go to configure instance details. So no change, no worries. This is not a EC2 AWS class, right? So I'm leaving everything default. So our purpose is to get the Kubernetes cluster up. Okay, then adding storage. Okay, leaving the default SSD 8 GB, more than enough for us, right? So nothing, it should be mounted here, and root. So okay. So adding tags. Okay, let's give a name here just for identification purpose. Let me give the name tag, and let's say this is our master. Yeah, even though that's why we need to understand that one as well, because as per Kubernetes standards, right? We don't say this one as a master node. It is control plane. That is the official word, right? Control plane. But since yes, you can see the name is going also node CTL, right? So we can just see node CTL. Let's use this name, right? And node control plane. So we'll just use the same name here, right? Node control plane. So that's going to be the host name for us, right? So this is in AWS for identification purpose, just a tag, right? So instance, this name will appear for the instance, right? Okay. So and name is, that's fine. And next configure security group. So no need to, if you want, you can change the name, but just time consuming. So let it be. Now, since it is the master node, right? Since it is a master node, I mentioned we need 6443. So just add a custom TCP rule and make it 6443, right? We need this port, so because this is where the incoming traffic is accepted from API server or from the control plane. So we need this port open in our EC2 instance where the master or the control plane is running, right? And custom, all right. So let's make it 00. I'm allowing all the traffic. So since it is the very first configuration we are doing, don't worry about those things. Just look at the whole objective is to get the cluster up and running, right? And okay, then review and launch. So very simple. I think we are done there. We can just review and launch it, right? And again, prior to that, this is our configuration, and we need the key, right? So let's create a new key here, right? Create a new key pair. So let's say control PL key, right? Control plane key, right? And we download it, right? All right, now we can launch the instance. Okay, so this is launching now. So let's try to connect to this one, and let me get the IP address. So this is my public IP address, and let me connect via mobile system. So I'm using mobile system. So also try to get used to mobile system because it's much easy, right? Rather than putty and not, right? Get used to mobile system. It's freely downloadable. Okay, let me open a new session here and SSH. So I'm using that my public IP here. Fine username, since it is a Ubuntu, the default username is Ubuntu. right? And okay, when it's trying to connect to mobile system, no need to convert those PPKs and not. You can right away use our private key here, and it will automatically convert. So I just downloaded the key, this one, and let me use that, right? And yes, so we try to connect here. Should be instance should be up and running by now, right? So all right, so we have it connected. So this is our private IP for the instance. That's okay. Right, so we have the first instance up and running, which is for the master, right? Which is for the master, right? Right. So let's get back to our documents. I'll be following the documents so that it will be easy for you as well. So the very next thing in this step is done. So step set the host name for each server. Yeah. So let's set the host name, and this is the host name for my control plane, what I'm working at the moment. So let me set the host name there, right? And yes, sudo host name. Yes, ndctltnh.com. That's okay. You can give any name. That's fine, right? So to make it effective, let me easiest way is to close it and reconnect, right? So now I think I should be having the yeah, I'm having ndctlpl. That's fine, right? So let me clear. Right, so that is that. Then the first thing is let's run a sudo app update as soon as the instance is launched. You better do a repository update like the yum update we are doing. So let's run the update. Let's see whether any updates are there. So let it run. Right, so it's yeah, that's fine. And step 2, sudo apt install curl and these packages, right? So you can, I will upload this document, so you can go to it. This just to install these 2 packages, right? We need it while we are doing the configuration. Right, so let me paste it here, right, and let it go. And so that is done. Output also I have given a bit, right? That's okay. Step 2 is done. Then step 3, add Kubernetes repository for Ubuntu. Yeah, we need what? Kubernetes to be runtime to be installed, and we need Docker to be installed, and those are the components in the cluster, right? Because we have certain components in the master node, we have certain components in the worker node, right? For example, proxy and node specifically in the worker node, right? The API server, control plane, and etcd, those things are in the master node. So anyway, it doesn't matter. I'll be going through all those things in more detail in the architecture explanation. So this is the hands-on I am doing first, right? So it's better to get the practical first, and rather than just trying to explain the architecture. So then you will get the, you will see, right? You will see how the cluster is coming up, and you will get familiar with the terminology. So after that, let's go to the architecture explanation later, right? Okay, so now let's add the repository for Kubernetes, right? So this command will, this is the key actually I'm adding for Kubernetes, right? Copy, yeah, I think, yes, that should be fine. Okay, here. Okay, and let's get the repository as well. Just to put the entry in the file. Yeah, so this output will be there, and a T will put the entry to the file, right? So likewise, right? Okay, so that is done, and then again run the sudo update just to update the repository, and so it will run it. Oh, sorry. Oh, did the mistake. Wait. Let's copy back here. Sudo app update. Yeah. Okay. So it will. Yeah, done. Okay, that's fine. So repository and is updated, right? Okay. Right. So then, yeah, any mistake here? Let's see. B6, 86 packages. That's okay. That's fine. That's fine. So it will be updated when I run it for the next time. So this is sudo app update. No, when I run the install, it will be fine, right? So that's okay. 86 packages updated, right? So then sudo apt and I'm installing vim and git, curl, wget, kubelet. These are the important things first. Kubelet, right? Kubeadmin, kubectl. Kubelet is not a must, right? Because master server does not need to have kubelet, right? Kubelet is just a process which should be run on the worker node, right? Which is to initiate the container runtime, right? And that's okay. So, but it's no harm to install it because due to certain practicals that we are doing might need it. So therefore, let's install these things at one shot, right? And yeah, this is still I'm working on the master node. Yeah, so let's install it. Yeah, now it is updating all of those packages, right? That's fine. And then we need to hold the versions. I mean, otherwise automatic updates will take place. We don't need to go there, and let's hold it on those particular versions, right? So that's fine. Yeah, on hold on the scope huddle, only these three, right? These three tools: kubelet, kubeadmin, which is we are going to use for our cluster initialization, cluster configuration. kubectl we are using to give the workloads, right? Deployments and all. This will be our client tool, right? And this is just a process within the master node. And as I said earlier, it should be in the worker node. Priority is on worker node, right? Okay, right. So and if you want to verify whether things are done, our client's tools and admin tools are installed properly. So you can just run this one and so it will give the version. So if the output is fine, yeah, we have the client version of that and we have the admin version of that. So I think we are done. Installation is good, right? And okay. Yeah, step 5 is to disable the swap. So that is a requirement on each node, right? So, and these are Ubuntu instances. So let's disable the swap. Yeah. Don't do that mistake what I did, right? So this just explanation, right? And use this command, right? That's the command, right? Sudo swap off, right? So let's first run this, right? From fs type is the way other things are mounted, right? So yes. And yes, sudo sap off minus a, so we will switch it off. Yeah, so you're done there. Yes, add the overlay module and the Docker network storage driver. Yes, we will enable this module, the kernel module, modprobe will enable the overlay module, right? Because overlay, we know, I think some explanation I have again. Overlay we need for Docker and as a storage layer as well as for the network driver, right? Storage driver, network driver. So that's why we are enabling that one. And so let's enable that. Yes, and there's another one called BR net filter. So this module is required to enable transparent masquerading and facilitate virtual extensible VXLAN and all traffic communication between the ports and all. So don't worry, we'll be doing a deep dive about Kubernetes port network. So in that, the masquerading and we can use the Wireshark and T-Shark and see how the masquerading and those things are working, and the VXLAN will be explained separately. For the time being, I just want to give you a definition why we are doing enabling this module VR net filter, right? So let's enable that one as well, right? VR net filter is done, and yes, this is for again I think IP tables, right? For firewall filtering, and also we need to enable these parameters. Actually, IP6 is not a must because we are on IP4, right? So if we just enable IP table, that is fine, but it's okay to run this command, right? So let's run it. So at once for IPv4 and 6 both. Okay. IP table filtering for bridge networking, right? So let's run that command. mistake. I think we can get a break here. We will continue after the break because the session again dragging. So let's have small little by little. Let's continue, right? So let me start the next session with this place, right? So IP table filtering. All right, I'll meet you soon in the next session. Okay, have a great time. Right? Bye bye.